I'm saying, right? Is this clear to everybody now?
Yes, sir.
Okay, very good. So let's continue. Now, I'm going to take it out so we can move on with what we were discussing initially. So I was just trying to say that if I know that metals, for instance, sodium, if I want to know the charge of sodium, it's quite simple. Because it is a metal, it is electropositive, so it's plus. Then the number I'm going to add is basically the number associated with the group. So just have that in mind, that sodium is in group 1, so it's going to be Na plus. That's plus 1 if it becomes charged. Magnesium is in group 2. Because it is a metal, it will form a positive ion, so it's going to be 2 plus. Aluminium is in group 3. So what is it going to be? Yes, I'm asking, okay, what is it going to be? Aluminium is in group 3. Okay, what is it going to be?
3 plus.
Exactly. Now, if it is a non-metal, let's look at something like, non-metals vary, but let's look at something like nitrogen. How many electrons are in the atomic shell of nitrogen? I am asking, yeah, the question is for favor. Yeah. How many electrons are in the atomic shell of nitrogen? Let me bring it up. Should I bring it up? See the periodic table. Yes? Okay. How many electrons are in the atomic shell of nitrogen? 5, exactly. So which means, look at this. Let's all look at this. You can mute the mic, please. Thank you. So we have that nitrogen has 7 electrons, but the one that is in the atomic shell is 5. So this 1, 2, 3, 4, 5, 6, 7. The whole concept behind the charge you have is simply based on the number of electrons that is accepted or lost for this thing to become completely filled. And to fill it, it is 8 that you need. So just have this in mind. To fill this atomic shell now, how many do you need? You need 8. Now the question is this. If you want this thing to be completely filled, there are 2 things you are going to do. It's either you accept 3 or you remove 5. So class, I'm asking, between accepting 3 to make it 8 or removing 5 so that it will now be empty and the atomic shell will be this one that is filled. You know this first one, what fills it is 2. So just have that in mind that once 2 fills this first one, it is still completely filled. The aim of reactions is to make sure that the atomic shell of electrons is completely filled. That is to attain stability. And to do that, you can either share or transfer. For electrovalent or ionic compounds, you're going to be doing transfer. So let's come back to this. Now, if I have nitrogen here, which one is easier? Accepting 3 electrons or removing 5? I'm asking the class. Anybody can answer. Which one is easier?
Accepting 3.
Exactly. It's easier for me to just collect 3 than for me to look for 5 different people to give out. So just note that it's easier to accept 3. Now, when it accepts 3, watch this. It accepts 3. 1, 2, 3. Now, let's find out the current charge of this thing. I mentioned before, if you did not write this thing before, if you have not taken note of this, take note of this. If an atom is neutral, comma, number of protons equals number of electrons. Please put this down. If an atom is neutral, number of protons equals number of electrons. Now, the other thing you are going to put down is that if you are asked to find the charge, charge is simply equals proton plus neutron. Charge is equals proton plus neutron. Sorry, I'm deviating from the topic we have at hand, but it's important to take note of this thing because these are the little places you will just get confused and then you will feel a lot of questions. Okay, I hope this is clear. Charge is equals proton plus neutrons. Does anybody have any confusion as with respect to this? Oh, sorry, protons plus electrons. I'm so sorry. Not neutrons, protons plus electrons. Protons plus electrons. Protons plus electrons. Are you there? Are we all done?
Yes, sir.
Okay. Okay, sorry, I'm trying. Oh, so C is equal to proton plus electrons, basically. Now, having said this, the implication is that if nitrogen has 7 protons, basically, and we're looking for the charge after it accepts, how many protons? It will be positive 7. Then how many electrons does it have now? Currently, now that they are accepted, how many electrons does it have now? How many electrons does it have now? Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the electrons is negative 10 because electrons are negative. So which means that the charge is going to be equals plus 7 minus plus is minus 10, and that is going to be minus 3. So what is going to be the charge of nitrogen after it accepts 3 electrons? It will be 3 minus. Sorry, is there any confusion? Do I have any question?
No, sir.
Okay, now the easier way of knowing this thing is, if you notice, let's do for oxygen. I'll show us the easier way to do it. If you are doing for oxygen, let's say for instance oxygen is 8, so it has 6. 1, 2, 3, 4, 5, 6, 7, 8. Now look, the implication is that for oxygen to be completely filled, it needs to either give out 6 or accept 2. And based on what we know, what is going to preferably happen? Should it accept 2 or give out 6? I'm asking the class. Answer. Exactly. Now let's accept 2. Now it accepts 1 and 2. Once it has accepted, the charge of oxygen will now be O. If it is accepting, electrons are negative, so when you're accepting them, you become negatively charged. How many things did you accept to become negatively charged? 2. So what is the charge of oxygen? 2 minus. Is this clear? Is this clear? Okay, very good. So having said this, all these things are clear. I just want to move ahead from here. So with that said, back to Arrhenius theory that we were discussing. We said that if you are dealing with dissolution of a particular salt in water, that once you dissolve or melt that salt would simply dissociate to form ions. That's Arrhenius theory, and it will give Na plus Cl minus, and that's that basically. So if we're going to put that down, let's put this down. So let's write sorry. Okay, so you put that down. It simply postulates that if an electrolyte is dissolved in water or melted, it dissociates to form ions. Full stop. The types of ions that are formed, as we know: anion, which is a negative ion that is formed by electron gain, and cation, which is a positive ion that is formed by electron loss. So put this down. Put this down quickly. Put this down quickly. Are you guys done? Are you guys done?
No, sir.
Okay, be fast. Once you're done, please tell me.
You don't need your calculator for this.
Students, are you not done? What's up?
It's many.
Okay.
Hope you need your calculator. Yeah.
Okay, so that's that. Now, there's an extra theory that was postulated. It's practically the same thing. The only thing is that instead of saying that in this Arrhenius theory, whenever you are dealing with these solids, they don't have charge at all. That's what Arrhenius is saying. That before the charge is produced, you have to dissolve it in water. But X-ray diffraction has tend to show that strong electrolytes, when they are existing, they exist with their charges even when they are in solid state. So when you are writing NaCl, if you write it like this is not exactly how it is. It is written like this. The only difference is that whenever you now dissolve it in water, this Na will now come out, split. Then this other one will split. So just take note of this. That the difference between this one is that in Arrhenius theory, Arrhenius is saying that it has not formed ion. Once it's in solid state, there is no ion at all. But the modified theory is saying that the ions are existing, but because they are positive and negative joined together, they neutralize each other. Sorry, do you guys get what I'm saying? Hello, students?
Yeah?
Did you guys get what I just said now?
Yes, sir.
Okay, so if you look at my screen, you will notice something. NaCl, there is no charge according to Arrhenius. This is Arrhenius zone. So according to Arrhenius, it doesn't have charge at all. So when you dissolve it in water, that's when the charge are formed. But the modified theory or the modern ionic theory is simply trying to say that the charges are there. It's just that because positive and negative comes together, it becomes zero. I hope people are following me now. It's just like if I have plus 1 minus 1. Class, plus 1 minus 1, what is it going to be? 0. Are you following? Ca, Cl2. Okay, who can tell me the charge for Ca? I'm coming. Who can tell me the charge for Ca? Plus 2. Thank you. Thank you. So the charge for Ca is 2 plus. But then the charge for Cl is going to be what? What's the charge?
Minus.
Exactly, minus. Now, what I want you guys to take note of is when you're writing them as charges, that's when you do the 2 plus. But if you're writing them out, you write plus 2. Then this one is minus 1. Remember that there are 2 Cl here, so it's minus 1 times 2. So when you add these two things, what is it going to be? 0. So the point is this. It is not neutral because there are no charged particles. It is neutral because the positive cancels the negative and it becomes neutral. Sorry, are you guys following what I'm saying?
Yes, sir.
Okay, very good. So with that said, simply write down the modified theory. It's practically the same thing, but just put it down just for the sake of knowledge. Now, X-ray diffraction shows that some strong electrolyte salts possess ions even in solid states. Hence, the modern theory is now saying that when you dissolve it, the constituents are not formed. They just split or they become separated. I hope it's clear. Okay, so put this down quickly so that we'll get into the other thing.
Rashid,
Are you guys done? Okay. Whoa. Okay, are you guys done?
Just okay now.
Okay. Okay. Okay, I think Okem can write from somebody's note. We don't have time. I want us to finish as much as possible today. Moving ahead. Now, how exactly does electrolysis take place? Before you write, I'll describe it. It's a very simple process. So listen. A very simple. Yeah, right. It's acting up. Now, if you have an electrolytic setup, you have the rods. Okay. Sorry. Okay, so we have this. Now, I have a question for, let's call this the anode. Then this is the cathode. Okay, so question for Glory. Glory, is the anode positive or negative?
It's positive.
Exactly. Remember that the anode attracts anions, and we know that anions are negative, so it has to be positive to attract it. But please, the anode is only positive in electrolytic cell. If you go to the battery, anode is now negative. Just have that in mind. Hope it's clear, class.
Yes, sir.
Okay, positive. Cathode is negative. Now, if I had, let's say I was dealing with NaCl and it dissociates to give Na plus and Cl minus, where would this Na plus go to? Will it go to the cathode or to the anode? I'm asking the class. Yes?
It goes to the anode.
Hey, Na plus will go to the anode.
Cathode, sorry.
Now, because it is positive, it will go to the negative cathode. And besides, I already said this thing. Cathode means cation electrode, which means cations will be attracted to the cathode. Then anode would attract anions, which are the negative ions. So we have Na plus and then Cl minus. Now, let's see what happens at the anode. First of all, class, what did I say happens at the anode? Oxidation, right? Sorry, are you guys following me?
Yes, sir.
Which means when the anion arrives at the anode, Cl minus gets here. What is going to happen to it is oxidation. And what is oxidation? Oile rige O ion radon. Oile rige O ion radon. O ion radon. Class, what do you respond? Good. So what is oxidation with respect to electron transfer based on what I just gave you? Is it going to be gain of electrons or loss of electrons? Think. I want you guys to fully understand this. Gain or loss? Gain or loss? Yo, nobody's answering. Favor. Is it gain or loss? Oxidation is loss, so we are going to minus electrons. Now, anytime you, okay, before I even continue, remember I told you guys something. I said that the reason these ions are coming here is so that they will be discharged. And when you are discharging something, you are making it neutral, removing it from charged state to neutral. So it will lose electrons and then it will become neutral. Cl, no charge. Now, but chlorine is a gas, and anytime a gas is existing, it has to exist as a diatomic molecule. That's why we put 2. So if we are balancing, we'll put 2 here. Is everybody still with me? Are you seeing how I'm forming this equation? Okay, now, in writing equations, you don't write reactant minus reactant. So because of that, we are going to take this minus E minus to the other side. So it will now be 2Cl minus reacting to give Cl2 gas. Instead of minus, when minus causes equal sign, it's become plus E minus. Now the question is, how many electrons did you lose for you to neutralize this guy? All you simply need to do is multiply this number here by the charge and you get your answer. So this is going to be 2 times 1. What is this going to be? 2. Is it clear?
Yes, sir.
Now, but please, for you to be able to do this simple method I used, the way to do this, or why you are applying this simple method, is because the charged particle is only on this side. What is here is neutral. If you have here is charge, here is neutral, you can do this times this and you get your answer straight up. Okay, who can tell me if, for instance, I had O2 minus. Okay, let's discharge this together. O2 minus, is it an anion or a cation? Unmute your mics. Let's join me in my analysis. I asked a question. No, anion or cation? Yo, O2 minus, is it an anion or cation? Okay, very good. Thank you. Now, it's an anion, which means it will go to the anode, right?
Yes.
And when it gets to the anode, is it oxidation or reduction? Anodic oxidation, cathodic reduction. So, see the things we are taking note of. Oile rigé. Then, anodic, yeah, O ion radon. Then the other thing we are taking note of is anodic oxidation, cathodic reduction. This is the only way you'll be able to fully understand and answer these questions on your own. Now, can I continue?
Yes, sir.
Okay, very good. Okay, so we'll be using Glory's mic. So, back to the board. So, I said oxygen is an anion. It will go to the anode, and when it gets to the anode, will it be oxidized or reduced?
Oxidized.
Thank you. It will be oxidized. Please, every other person in the class, are you people following what I'm doing?
Yes, sir.
Okay, very good. Thank you. So let's continue. So it's going to be oxidized. So gift oxidation, is it gain of electron or loss of electron? Gift oxidation, is it gain of electron or loss of electron?
Loss of it.
Thank you. So we are going to minus electrons, and then it will give the neutral version. Here is charge, so here should be neutral. So what's the neutral? O without the charge. But oxygen is a gas, so we are going to write O2 gas. Please, is this reaction correct? What is the wrong thing about this reaction? Who can tell me? It's not balanced. One.
It's not balanced. And reactants are not supposed to
Thank you.
be
So
together.
you are not supposed to have minus reactant minus reactant. It doesn't work. So this guy has to go over, and then we balance our equation. So our anodic reaction will now be, our oxidation reaction, which is anodic oxidation reaction, let's call it AOR, is going to be equals O2 minus, if it crosses over, reacting to give O2 gas, then plus E minus. Alright, let's balance. How many oxygen is here? 1. How many is here? 2. So we put 2 here. Now, because here is neutral and here is charge, please, how many electrons will be here? Okay, how many electrons will be here? How many electrons will be here?
2, sir.
Why will it be 2? I said you multiply this number by the charge.
Minus 2.
It's not 2, it's
2
4.
electrons.
It's 4. This number, the number of moles is multiplied by the charge. So 2 times 2, what is it going to be? 4.
4 electrons.
Here we did 2 times 1.
4.
Yeah. I hope it's clear.
Just
You can mute your mic. Okay, very good.
start.
Okay, thank you. You mute your mic. Mute your mic. Okay, this question is now for gift. Gift, if I had N3 minus, will I oxidize or reduce? Okay, see the first question. Gift, are you with me? I think the clearest mic in this class is Glory's mic. So gift, if you are close to Glory, please use her own phone. Thank you. So gifts, can you hear? Okay, so now first question is this an anion or a cation? You are not sure?
I am.
K positive ion. T is like so K positive, that's cation is positive. Anion is a negative ion. So what's the answer? Is this negative or positive? Anion. Thank you. So is anion. since it's an anion, is it going to be going to the cathode or the anode? I'm still talking to Gift. Thank you. When it gets to the anode, will it be oxidation or reduction?
Oxidation.
Thank you. Now, what is oxidation? Gain or loss? Sorry, what did you say? Very good. So minus electrons, and then to give nitrogen. But you know nitrogen is a gas. I gave you guys an assignment last week. Don't think I forgot. Nitrogen is gaseous in at room temperature, so it's going to be N2 gas. Now Gift, are you still with me? Thank you. So let's go ahead. Now, what's the thing that is wrong with this equation?
The both reactants are on the same side.
No, it's not both reactants. You don't write reactant minus reactant. Do you understand? It's possible if it was plus here, then you don't need to move it. But because you have reactant minus reactant does not make sense. So what's going to happen is we'll move this to the other side, and it's going to be N3 minus reacting to give N2 gas plus E minus. So far, I hope it's clear.
Yes, sir.
Then what is the second thing that is wrong with this thing now? It's not balanced. So let's balance. 2 nitrogen here. How many will be here? Gift.
2.
So what's the charge? How many electrons?
4. Yes.
4.
No.
2 times 3 is 4 in your village. Gift, where are you from?
Sorry.
Gift, where are you from? How would 2 times 3? I mean, you did not go to primary. I'm pressuring you. Oh yeah, what's the answer? Don't mind me. What's the answer? I'm just playing. What did you say? 6. Okay, correct. So that's that. Please, every other person in the class, did you people understand what I just did?
Yes, sir. Yes,
Okay,
sir.
very good. Now, let's try for positive. Let's try for positive. Let's try for positive.
I have one question.
Go ahead. Yes, go ahead.
So I have a question.
I'm listening.
So if we want, if you want to get, if your mind, if you want to get the electrons, you have to multiply the distance and the charge of it.
Yes, you multiply the number of moles and the charge to get the number of electrons. But before you do that, please listen. Before you do that, make sure that one side is charged and then this other one is neutral. Because if here has a charge, it will not work. Did you hear what I said?
Yes, sir.
Okay, so just make sure that here is charged, this other one is neutral. Once it's charged and neutral, you can use it. But if you have one here, something is charged, and then on the other side, something is charged, then you cannot use this my method. I'll still explain how to do it as we go further. Sorry, I hope we're making sense.
Yes, sir.
Okay, so moving ahead, if I don't have any other question, let's just okay, so let's try for positive. It's the same principle. It's exactly the same principle. So let's get to it. Now, look at this. Na is a cation. So let me ask, is it going to go to the cathode or the anode? I'm asking Favor. Favor, you can use Glory's mic. I did not go into the exactly. Now, when it gets to the cathode, will it be oxidation or reduction? Remember, this is the emphasis. Look at this. Remember, oil reggae, O-ion radon, anodic oxidation, cathodic reduction. This is the emphasis. So, if Na plus being a cation goes to the cathode, what is going to happen there?
You undergo reduction.
Thank you. Now, what is reduction based on oil reggae, O-ion radon? Is it gain or loss? Thank you. So plus electrons reacting to give. Now remember I told you that the reason you are doing this discharging is so that it will become neutral. So remove the charge, it's now going to be Na neutral. Now please, do I need to carry this electron to the other side? I'm asking the class. Do I need to carry the electron to the other side? Exactly, because this is reactant plus reactant. Okay, so now how many electrons will be here? Who can tell me? How many electrons will be here? Oh my. Hello? Hello?
Sorry, Victor.
Hello, Nye? Hello? They're trying to form Nigerian accent. It's only a Bishola.
African accents. It always goes back.
Very bad.
If this is the idea they have of us, it's not correct.
Yeah, Nancy, how far? Are you in class? Okay, it's alright. Why I called, Sha?
It's not a joke. This is how they do it every
I need cash, but I'm going to pay it like before weekend. Yeah. You understand? They are going to pay me. They were supposed to pay me today, but I don't know what's happening. They are delaying. You get, and I really need cash. I'm going to pay 5k. Is it possible?
But not to that correct level where those
And please send it to me now. I beg.
and then
Thank
be
you,
taking
guys.
earlier
Thank you
to
very
go out.
much.
And the same collect you are collect. Yeah.
Have you listened to Odumeje? He talks exactly like that now. Odumeje talks like that.
Is it like that guy in that place? Try to do that. That's what I'm telling him now. That there are people that talk like that. I don't know why, but I have a feeling Calabar people talk like that.
Sorry for the interruption. Are we still here? Okay, so I was saying something. What was I even saying? Yeah, a call came in. So I said, if it's a metal and the ion is here, if here is charged, here should be neutral. That's basically what happens. So we have this. Now, if you have Na plus E minus reacting to give Na, you find out that the charge of the metal is the same thing as the number of electrons transferred. Are you guys noticing this? So if I happen to write this now, Al3 plus electron to give Al neutral, how many electrons do you think will be used? Eh? 3. Exactly. So just note that if it is Ca2 plus, Ca2 plus is cation, right? Right?
Yes, sir.
So will it go to the cathode or the anode? It will go to the cathode. When it gets to the cathode, reduction. So plus electrons to become neutral. How many electrons? 2. Sorry, I hope everybody knows how to write down these equations now. I hope everybody knows how to write down these equations now. Okay, good. Now with that said, I think you guys can put down this note. Just put down the notes quickly. Oh wow.
Can you season?
Sorry, I think I put off.
The gay season has most of the seasons have been gay. It's like gay.
Okay. Sorry, it's taking time to load. Okay. While it's loading anyway, um, what did I want to say now, sir? I was thinking of sending this slide later so that you guys will write it later. So I will just continue with
That
discussion.
you just send it. You just send it. Just write it down.
Sir, ma?
That you don't use to let them write
Okay.
it down.
So, or should I just send it right now so that everybody has it now? So that we'll just
Okay, I
continue.
send here.
It will save us time of writing. You get. Let me send. Let me send it now. I don't know why it's taking time to load. So that everybody has it. So that I'll just be describing. You get. So who am I sending the slide to? Exactly.
Anti-grace, anti-grace.
Auntie Grace. Can you tell Auntie Grace to chat me up so that I will know?
Okay, sir.
Okay, guys, can you hear me? I've sent it though.
Thank you, sir.
Okay,
Yes, sir.
okay. So with that said, let's just move ahead. Now, why I sent it is so that we would not need to be writing excessive notes. It takes our time, sincerely. Writing these notes takes time. Since if we have this live, you don't need to be writing notes. Since I have them prepared, you can just be looking at it as we go on in the class. Just make sure you go through it. Now, blah blah blah. It's just grammar. When you connect the battery, I already explained what happens now. I told you that if you have a cathode, the cathode being negative is connected to the negative terminal, and that negative terminal will pump in electrons. That's why we said cathode is the electrode through which electrons enter and current leaves. Hope you guys remember. Hello?
Sir, come again.
I said the cathode is the electrode through which electrons enter and current leaves. Do you remember?
Yes, sir.
So you remember I said that. Now, which means the anode is the electrode through which what happens?
The anode is the electron in which current entered and electrons.
Exactly. So it's just the opposite. I hope what we are saying is making sense. Good. Okay. Now, having said that, I don't need to talk much or say emphasize so much. They just talk about why it's connected, blah blah here. There's nothing much. The negatively charged cathode then attracts cations to itself, which I explained. Cations accept electrons to become electrically neutral and eventually discharge. The positive terminal cathode of the battery draws electrons. You know this, you know this. I've just described them, so we don't need to overemphasize. Now, redox in electrolysis is also what I have done. When I was telling you that oxidation occurs at the cathode, the major emphasis in that redox in electrolysis is this. You know, if just put this down in your note, I want you to write this down. Just write redox in electrolysis, then you write NB. Redox in electrolysis, then you write NB. If an ion is formed by a process, this is what I want you to write. This one. If an ion is formed by a process, it is discharged by the opposite process. Hence, if an ion is formed by gain of electrons, that is for anions, it is going to be discharged by loss and vice versa. Please put this down. I want this one to be in your note. Have you people finished writing this thing down? Are you done writing? I'm coming. We don't have time. Jump is in barely 6 weeks, and we have a lot of things to cover. That's why I'm trying to hasten up so that we will not over stress some things. Everything is important though. The truth is that we don't know where they're going to come from. That's why I'm trying to touch every single and possible angle, but we need to be doing it with speed. You get what I'm saying? So we need to emphasize speed now, so everybody should just be alert. I'll be giving you topics to go and read ahead so that when I come back, we'll just look through it. I could send links to some studies that have been done so that you pre-study them, already recorded study. You pre-study them. When we come to class, we will majorly solve questions. For instance, solubility. I'm going to send across the link for solubility to Uncle Miracle so that you just go and pre-study it, look through the slide, the videos, so that when we come to class, we'll now just start solving questions. I won't need to over explain things because we don't have time. That's the only way we'll cover. I hope everybody's understanding what I'm saying.
Yes, sir, we are done.
Okay, very good. Now, the emphasis here is this, that if I say that an anion is formed by a process, if you want to form anions, you gain electrons. So which means to form anions, remember it is neutral. Let's look at this. It used to be neutral. Then you gain electrons. Once you gain electrons, what does it become? It becomes an anion. Now if I want to return this anion so that it becomes neutral again, please, what am I going to do to make it neutral again? Who can tell me? Who can tell me? So what is distracting us exactly? I want to know. Let's talk about your distraction. Eh? Okay, it's all right. So let's come back. Okay, so back to us now. Listen. If you have a neutral substance and that neutral substance gains electrons, hope you know it will become an anion. Because if something that is neutral gains electrons are negative now. If something that does not have any charge at all gains a negative charge, what will happen to it? It will become negatively charged. We proved that in our illustration earlier on in the class. Did everybody get this thing I just did here? Okay, now, which means if I want to convert this anion and make it neutral again, how am I going to do it? How am I going to do it? Oh, am I going to gain electrons or lose electrons to make anion to become back to neutral? I converted neutral to anion by gaining. So how am I going to convert anion to neutral? Lose or gain?
By losing.
So that's that. Please, this loss of electron, is it oxidation or reduction? Thank you. And where does this occur? It occurs at the anode. So you see that in electrolysis, anytime an anion is attracted to, let's look at this. Anytime an anion is attracted to an anode, because the anion was initially formed by gain of electron, what it will need to do here is loss of electron, and that is oxidation. So that is why we say that the anode undergo oxidation, or anions undergo oxidation at the anode. On the other hand, cations, when they get here, so let's do the illustration for cations. Okay, so cations, let's go. It used to be neutral. What do I need to do to make it a cation? I remove electrons. It becomes a cation. And when it becomes a cation, I want to make it to be neutral again. Please, how am I going to make it to be neutral? I lost to make it cation, which means if I'm converting cation to neutral, I will need to gain electrons. And this is what? Reduction. So please put down this equation. Put this down, and then we will continue, because this is all for electrolytic processes that occur in electrolysis. Be fast. Read up the slide. I explained it well in such a way that you can actually answer questions, but please go through the slide. Remember, I have not forgotten my assignment. I am still going to ask my questions and collect my 500 naira for not doing assignments. You guys will feel I'm joking till the day you will come to class and they will tell you that you can't join my class because you've not paid for assignment fee. Okay. Oh yeah. Oh. Yes, now dollar is now 1,900 though, so you people will know.
Money.
I can't hear you, Gibbs. Your mic is. What did you say?
I feel like you have to make extra money.
Yes,
So
now
that's prohibited. You know,
it's not prohibited anything. It's allowed. If you do your assignment, I will not collect. It's punishment. I cannot flog you from where I am, so I'm going to flog you by collecting your money. Now, having said this, the next aspect of our study, are you guys still with me, that we are going to get into is what we refer to as preferential discharge. So please, I want you to write this one down. Write this one down. Factors of preferential discharge. Now, before you write down, listen. You know, we said that when you dissolve, for instance, NaCl in water. Are you guys listening?
Yes, sir.
Good. NaCl will split to give Na plus and Cl minus. However, because it is inside water, water undergoes partial dissociation to give H plus and OH minus. So notice that how many cations do you have? 2 cations. How many anions do you have? 2 anions. Are you still following me? Hello, are you still with me? Good. So the question, thank you. The question now is, between sodium and hydrogen, who will you choose? Are you going to discharge Na plus or discharge H plus or discharge 2 of them? Which one is it going to be?
600
Which one is it going to be?
Sorry, sir.
I said, are you going to choose Na plus to discharge it, or choose H plus to discharge it, or discharge 2 of them? How do you discharge? Because the 2 of them will go to the cation, the 2 of them will go to the anion. So who are you going to discharge amongst them? Here now, who is going to are you going to take amongst these 2? When these 2 get to the cathode, who are you going to take? When these 2 get to the anode, who are you going to take? Okay, so we'll discuss this. The point is, once you have multiple choice or like multiple options, that is where choice comes into play. If for instance I tell you you came back from school and there is only apple in the house, do you have choice or what to choose? You don't have choice. But if you now have a situation where there is fried rice and chicken and there is like fufu, I'll still eat fufu anyway. I think I would prefer fufu to fried rice and chicken, but fufu with you are going to prefer fufu too, right?
Me, I prefer fufu. I don't know about you.
You prefer fufu, right? Glory, which would you prefer, fufu or fried rice?
Fried rice.
Ah, it's all right. So if somebody takes you at night, fried rice you go and eat. It's fufu abeg, so your stomach will full. Now the point is this: the only reason you have choice of fried rice and fufu is because there are multiple options. And once there are multiple options, you will need to choose one. Are you getting what I'm saying? Hello, are you following?
Yes, sir.
Okay, here now, do you think there will be need for choice here? For preference, if I have H plus, and then OH and Cl minus. In this side now, do you have choice? Is there any choice? They are the same thing. Is there any choice?
No, sir.
Exactly, because they're exactly the same thing. So where you need to do preference is when there are multiple choice. And there are certain factors that we are going to be considering for us to be able to do those preferences. Now put this down. Put this down quickly. Put this down quickly. You have the note. So I'm just going to be highlighting the most important points in that note. I think I actually stated it straightforward, Seth. Okay. Okay. Now put this down. So that's how we're going to be doing it. For us to save time, I'll send the slide across. You guys are going to have the slide and go through it, which is the complete study. But what we're going to be doing is highlighting and explaining the most important points for you to be able to answer jam questions in the class. Okay? You don't need to waste time. There is no time to waste. Are you done? I want to move ahead from this. We have a lot of things to discuss. Okay. Okay, before I even continue, the element for this week. What was the element for last week?
Hydrogen, oxygen, and nitrogen.
Okay, it was the first. Wait, the first week was hydrogen and oxygen. I know.
And you question was,
Then I now added nitrogen, ba? Right?
Yes, sir.
Okay. So to glory, you said yes, sir, right? Glory.
Sir?
Yes, your first question. Your first question. Listen, before we continue.
Yeah, you said friend.
I said, your first question, glory. So what is the product? Glory, are you here?
Yes, sir, I'm hearing.
Okay, good. What is the product of thermal decomposition of this compound? What gas will be given off? What gas will be given off? If I thermally decompose this compound, what gas will be given off? Okay. If I thermally decompose this compound, what gas will be given off? Okay, this is your question. This is glory. This is okay. Don't see. Okay. Oh yeah. Glory, this is your question. Be fast. Then, what's her name? Gift. Thermal, a reaction between ammonium chloride and calcium hydroxide would give a particular gas. What is the name of the gas? Then finally, favor. Thermal decomposition of PbNO3 will give out what gas? Oh yeah, glory. What's the answer to your question? If you don't have it, you give Auntie Grace. Okay, each question is 100 naira. So give her 100 naira. If you don't know the answer, just give her 100 naira. Yes, glory. What's your answer? Glory. If you don't know, you say you don't know it. I don't have time. I want to. Let Okem talk first. Okay, you know Okem's own. Okem, do you know Glory's own? Okem. Okem, do you know your own? Okay. Are we all disconnected? What's happening? Glory, your mic is the clearest. Thank you. Now, Glory, your mic is clearer. Can Okim answer with your mic, please? Because his own is very noisy. You get? Okim? Okim, don't unmute your mic. Yes, Okim. Do you know the answer to your own question?
Yes.
Good. Okay. So answer your own first. Let's start with that. What's it going to be?
N2O plus H2O.
Correct. Yes, Gift. What's the answer to your own? Gift. What's the answer to your own? Gift, if you don't know it, just say you don't know it though. We don't have time. If you don't know it, say you don't know it. So I'll move ahead.
So let me say the answer to my own.
Oh yeah, go ahead. What's your own?
To give you N2 plus H2O.
Correct. Makes sense. You guys read this. Yes. Wait, oh, Glory. How did you get the answer? You looked at your note or textbook. Glory, don't lie.
It's not that like. It's not.
Eh? She googled it, right?
You don't do it.
No, I'm talking to every other person. Please keep quiet. I'm not talking to you. I'm talking to Glory. Glory, how did you get this answer? Did you remember it or did you look it up?
Because when you were
Last week I mentioned
When
this.
you were teaching rich stuff, so I jotted it down.
Yeah, I mentioned this last week. Okay, so gifts, yes, which means you looked at your note to get me an answer. Okay, still no worries, just make sure you go through nitrogen again. Gift, what's your answer? Gift. Oh,
Tell me, I don't know.
okay, very good. Now anytime an ammonium salt, any ammonium salt, please everybody put this down. If an ammonium salt is reacting with an alkalis is a soluble hydroxide of a metal.
Sorry, please, can you come again?
If an ammonium salt is reacting with an alkalis, ammonium salt plus alkalis, it will give ammonia. Ammonium salt plus alkalis will give salt. The salt it will give will be CaCl, but it will be CaCl2 now, water, and then ammonia gas. This is like a constant something. So everybody look, NH4 bracket 2SO4, and it is reacting with NaOH. Who can tell me the product based on what we just said? Yes, who can tell me the product? Is this an ammonium salt? Can't people hear me?
We can't.
Okay, good. So I'm saying something. I said if you have an ammonium salt reacting with an alkalis is a soluble hydroxide of a metal. Put that down. And the soluble hydroxides are sodium hydroxide, potassium hydroxide, and calcium hydroxide. Those are the ones you need to know for your level. There are more, but these are the most important ones.
So, come
Soluble.
Sir, please, you are too fast.
An alkalis is a soluble hydroxide of a metal. Alkalis is a soluble hydroxide of a metal. Soluble hydroxide of a metal. And they include sodium hydroxide, potassium hydroxide, calcium hydroxide. This one is not so soluble. This one is slightly spelling of slightly, man. Slightly soluble. Okay. What's up? Are you guys there? Are y'all students? Wow.
Huh?
Okay, so are you guys still here? Have you written this?
Yes, sir.
Now, I now told you guys, leave your mic on. Thank you. Leave your mic on. Whose mic was on? Whose mic was on? I think it's Glory's mic. Thank you. Now, I mentioned something and said that once an ammonium salt is any salt that has ammonium ion. Once an ammonium salt is reacting with a base or a soluble hydroxide, it will give salt, water, and what? Ammonia gas. And this is a popular question that comes out. Which of these is produced whenever a soluble gas, an alkalis, reacts with an ammonium salt? The gas that is produced is ammonia gas. Now, how do I form the salt? This guy will join to this guy and form the salt. Then you write H2 and write ammonia. So who will tell me the product for this one? Yes? If you want to give me the answer, please put your hands up. Where did Favor go to? Has she gone home? Glory, where did Favor go to?
over the around.
Okay.
I phone is below card.
It's alright. Okay, so does anybody know the product for this one I gave?
One day,
Does anybody know the product? The answer to this? It's simple now. Form the salt. You don't need to balance it first. Salt is join these two. This is going to be Na2SO4 now. Do you know why? You know SO4 is 2 minus now.
yes.
So yeah, so that's that. So plus water. Then you simply write what? Ammonia. That's all. So once you notice ammonium salt reacting with base, this is your only product. We'll discuss more of these reactions as we go further, but let's take a break for now and come back to what we are doing. Okay, so I'm wiping this out. So then finally, Favor, use Glory's mic. Favor, Faye. Favorite favor.
Sir.
Thank you. So what's the product for this one?
Sir.
Don't be blushing though.
It will give us
To give us what?
it will give an oxide of metal, that's
PBO plus
PbO plus CO3 plus oxygen.
no NO2 plus oxygen. Clear?
Yes.
And I think I mentioned this in the last class, sir. This is what we refer to as
Yes, sir.
this is one of the lab preparations of nitrogen oxide. This one is lab preparation of ammonia. This one is lab preparation of laughing gas. This one is lab preparation of nitrogen. Is this clear?
Yes, sir.
Because now so they do me oh. Some of the times I'm teaching in class and I just divert and start talking about something and that thing comes out in exam. It has not happened once, it has happened so many times. You get okay, I've had a lot of students under me and I have a lot of people that have performed well. So if you follow what I'm saying, you will definitely perform well. Now, the elements for this week, in addition to nitrogen, you people failed nitrogen. I don't like you people were just looking through your notes and internet.
Sir, wait, sir.
What happened? Yes, gift. What happened?
That's Friday. Well, we have it, sir. For
You have what?
so, but it's just Friday now. So we have not.
And they are changing the timetable. Normally it's Friday I take chemistry, but they said chemistry.
No, you don't take classes on Friday, sir. You take class Friday.
Okay, I'm going to like discuss with the management and get a constant timetable so that I'll be giving you guys specific days that you people will not fail. So now your coursework has increased. You now have hydrogen, oxygen, nitrogen, and carbon. These are your elements. Everybody should study this thing before the next chemistry class, and that is going to be Friday. So study it before Friday. Did you get Friday this week? Hope everybody understood.
No, sir.
Whether you understood or not, you heard me. You can study all these things in 24 hours. That is today. If you go home and read,
So we don't have that 24 hours.
you definitely have 6 hours to spare me. If you decide to do TDB today, you finish it and you will still come to class, and you can sleep 4 hours today. You can decide that today you are going to sleep for 4 hours and then make sure you finish this thing. You have 6 weeks to jump, and some of you want to do medicine and surgery. Abeg. Let's continue, Jerry.
Nobody do medicine and surgery. Yeah.
My sister will say this.
You people that are not doing medicine and surgery, say some of you are applying for OAU. You think OAU is easy to get? Do you see their quota?
Nobody apply for it.
What schools are you applying for? Yes, I want FUTA. Who else? FUTA. Who is applying for FUTA and what course? I want to know all your courses and what schools you are going for. Who is this? Who is talking now? Sorry. Favor is going to FUTA. What course? Computer science. Okay, good. Glory. Lasso. What course? Nursing science. The next person, and you would think is not different from medicine. Well, who is the next person? Gift. Did you not register for JAM? What course are you going for? What school?
Computer science.
Computer science. All of you want to be tech girls, okay? What school? What school? Unilag. Okay, then Okem Sinachi. What school? What course? Okem is not.
I'm going for microbiology. I don't know the school I'm doing.
I get key. Microbiology. Okay. Did you say microbiology?
Yes, sir.
You have not registered for JAM yet.
You have it.
What school did you register? UI.
I don't know yet.
You registered the which one is you don't know? You registered JAM. How wouldn't you know? Anyway, let's just leave the jokes and continue class. Now, as I was saying, I just wanted to like encourage you first to study hard. 1 mark can make you lose out on your admissions. You might be saying it's not competitive, and you now come and misdo and come and get 201, and they will now cut 202. It has happened to me too before. Are you getting what I'm saying? So please strive to get them 300s so that you'll be sure that you are in school. You get, I have so many tech guys, that's tech, tech, most tech and engineering guys do not consider high jam scores, but I had to encourage them, talk to them, and the ones that listened, when they were boosting their 300s, they did not need to read too much. One of them had 334. With, even if he has 200 in pursuit TME, he will definitely still get electronics engineering. He's currently in final year. Are you getting what I'm saying? The other one has, most of them are actually done with school now. You get what I'm saying? So just have that in mind, that once you are going for any course, it's best to put in the best you can, get the highest possible score you can, so that you will not be like, it's 1 mark that made me to not get admission. Alright, let's continue. Now, having said that, I think I've answered these 4 questions. Let's come back to what we are saying. Now, you've written that these are the 3 conditions of preferential discharge. Have you all written this?
Yes, sir.
Okay, very good. Now, the simple trick or conclusion of this thing, let's start with the first one. Right, number 1, position in electrochemical series. Write it down. Position in electrochemical series. Then you write this statement: the weaker ions are preferentially discharged. Just write that statement. The weaker ions are preferentially discharged. The weaker ions are preferentially discharged. Now, after writing that, you put a full stop and then write: the less electropositive or less electronegative are the weaker ions. The less electropositive or the less electronegative are the weaker ions. And they are preferentially discharged. So what does this mean? Are you guys done writing?
Sorry, sir, please come again.
Come again
The
from
less
where?
electropositive. The
And
less electropositive.
or is it and?
And the or.
Which one did I say, sir?
And the or.
The less or less electronegative ions are preferentially discharged. Are preferentially discharged. Oh, sorry, no, that's not what I said. The less electropositive or less electronegative are the weaker ions and are preferentially discharged. Are the weaker ions and are preferentially discharged. Have you guys gotten it? Have you guys gotten this thing? Okay, so having said this, now please listen. Please listen. Listen. The first illustration, you can mute your mic. The first illustration I would give, where is my pen, is if, for instance, there is war in a city. Let's use the Ukraine war, which is one of the popular wars we know of this current time. If there is war in a particular city and you have men, women and children, men, women and children, please, who are they going to preferentially take out of the country? That's discharged from the country. Are we going to be taking away the men or the women and the children? So sorry. We are going to take out the women and children. Why? Because I'm not calling women weak, just in case. Okay, yeah, thank you. I'm just saying this, that I'm not saying you are lesser than men. I'm just saying that there is a general concept with respect to strength that indicates in most cases that women and children are the weaker ones. Hence, they are taken out of the country, while the men will stay in the country and fight. I hope this is fully understood. Hello? Did you guys grab what I just said? Now, the next, let's bring this thing to electrolysis. If you have Na plus and you have H plus, the first thing you need to ask yourself before you know who will be discharged by, this is a cathode now. She is cathode now. Are you following? At the cathode, will it be discharged by oxidation or discharged by reduction? I've said this thing so many times that by now it should be in your head. anodic oxidation, cathodic reduction.
Doctor.
Thank you. Now listen, we would need to first check between the two of them who is stronger, and to be able to check who is stronger, you will need to know the electrochemical series. Now, electrochemical series is simply the arrangement of ions in an order of increasing standard reduction potential. Please put this down. Yeah, put it down. Electrochemical series is the arrangement of ions. Electrochemical series is the arrangement of ions in an order of increasing standard reduction potential from top to bottom. Electrochemical series is an arrangement of ions in an order of increasing standard reduction potential from top to bottom. Electrochemical series is an arrangement of ions in an order of increasing standard reduction potential from top to bottom. Okay? Are you done?
Come again.
Electrochemical series is an arrangement of ions in an order of increasing standard reduction potential from top to bottom. Now, basically, to the layman, if I'm to describe standard reduction potential, where I want to discuss it is when we start dealing with electrochemical cells. But just for the sake of understanding something, to the layman, look at the statement: standard reduction potential. Who can tell me what you think is the definition of reduction potential? Yes? Yes, we are science students, we have sense, we are analyzing this together. Reduction potential. What comes to your mind when I say reduction potential? Nothing. Okay. Yeah, I get increase in electronegativity, but the point is reduction potential is the potential to be reduced. Do you get what I just did?
Yes, sir.
So to the layman, it is simply the potential of a substance to be reduced, and that means it is the potential of a substance to do what? To gain electrons, because reduction is gain of electrons. Are you following my analysis?
Yes, sir.
Okay, good. Now, but we don't need that understanding here. Where we will need that understanding is when we are dealing with battery. So let's just leave it for now and come to what we need here. What we need to understand in this table is that anything that is up, anything that is above, that is between king and O, you know that this is potassium, calcium, sodium, magnesium, aluminium, zinc, iron, tin, lead, hydrogen, copper, mercury, silver, gold. You know that, right? You guys know this, right? And this is hydroxyl ion, iodine, bromine, chlorine, nitrate, sulfate, and fluorine ion. These are the popular ions you need to know. Okay, let's come back. So let's come back. Now, please listen. These ones that are up for your positive ECS, this is called the positive ECS, the positive ions. The ones that are up are more electropositive, so they are stronger, while the ones that are down are less electropositive, so they are weaker. Here it is the opposite. The ones that are up are less electronegative. You know, when we are dealing with negative, we are dealing with electronegative. So the ones up are less electronegative, the ones down are more electronegative. Are you following what I'm doing?
Yes, sir.
Okay, so with that said, between sodium and zinc, who is stronger? I'm asking a question, class. Between sodium, Na plus, sodium is stronger. Good. Now, if I'm going to do a preferential discharge, am I going to discharge sodium or am I going to discharge zinc? Based on what we just said.
Discharge. I'm going to discharge zinc.
Exactly. Why am I discharging zinc?
Because it is weaker.
Exactly. So just have that in mind, that the general principle of preferential discharge, or the first general principle, is that in a competition between ions, the weaker ion is preferentially discharged. Hope this is understood.
Yes, sir.
Okay, so with this understanding, we are going to consider the electrolysis of aqueous sodium chloride. Oyao, you can put that down as your example. Example: electrolysis of aqueous sodium chloride. Electrolysis of aqueous sodium chloride. Now, in the analysis, the first thing you need to take note of is what are the compounds. Then you write out your cations and your anions before you start your analysis. Now, sodium chloride is NaCl, and I told you that once you say something is aqueous, it means that the solvent there is water. So it means you combine NaCl solid with water. Once you combine it, it becomes aqueous. Now please, what is the cation in NaCl? Na plus. What is the anion? Cl minus. What is the cation in water? H plus. What is the anion? OH minus. Is there any confusion with respect to what I've said so far? Class, is there any confusion?
No,
now let's move ahead. Now listen. Now these cations, where would they go to? These two cations, where would they go to? Where would the two cations go to? Cathode or anode? Thank you. So when they come here, Na plus and H plus, between the two of them, who will be discharged and leave this solution? Look at the table. Look, let's look at it. So this is sodium, this is hydrogen. So between them, who is going to be discharged? Who will be left in the solution?
Hydrogen.
Hydrogen will be left or discharged? Yes, we've been analyzing this thing together now. What's up? You guys can't hear me. It seems it's lagging. Your service is quite bad. Are you guys saying anything? Because I can't hear anything.
So nobody saying anything.
Oh, so Glory. Glory, I'm asking Glory. Glory, can you hear me? Glow. Glory is no longer in class.
Yeah.
Why can't she? I can't hear your mic. Oh, Abi, you're not talking.
Oh, they cannot hear you rather.
Okay, so let's. Can you use Gift's phone?
Yeah, come on, it's
Okay, so Glory, are you listening?
Yes.
Thank you. So my question is this. Please listen. That between let me take this out. Between sodium and hydrogen, who will be preferentially discharged based on what we just said?
Hydrogen.
Why will hydrogen be preferentially discharged?
Because hydrogen is a weaker solution.
Weaker ion, not solution, ion. Every other person in class, thank you. Every other person in class, hope you guys understood what I'm doing. Excuse me, every other person in class, hope you guys understood.
every other person in class. Okay.
Yes, sir.
What happened? Can't you guys? Hello, are you guys not still in class? What's up?
The Glory has people left the lecture for their back.
Okay, so can you guys all hear me now? If you can hear me, please put your hands up. Okay, very good. Hands down. So let's come back. So you are going to help me write down this equation. Who is going to help me now? Gift. Oh yeah, Gift. Let's write the equation together. Gift. The cathodic
Yeah, I can hear you.
half cell equation or cathodic reduction equation. Let's write it together. Now between the two of them, Glory chose H plus, so we are going to be removing H plus. Now if H plus is going to be removed, will it be discharged by oxidation or by reduction? Gift.
Reduction.
Thank you. And because it's reduction, will it be gain of electrons or loss of electrons?
Gain of electron.
So plus electron. And when it is discharged, it will give neutral hydrogen. But hydrogen is diatomic, so we'll write 2. It's a gas. So balancing, we'll put 2 here. How many electrons will be here? How many electrons will be here?
No.
How many electrons will be here? Exactly. And that is that. You are done. So which means we have removed hydrogen from this side. Are you people following? Now notice that sodium is here. Now let's do for the anion.
Yes, sir.
Let's do for the anion. So we have Cl minus and OH minus. Oh yeah, let's look at this. Let's find our where is this thing? Now look, for negative, look, negative is the opposite. The ones that are up are weaker. The ones that are down are stronger. Are you following? That's why here the sign I have here is no. Don't choose the lower ones. For negative ECS, choose which ones? The upper ones. Sorry, are you guys following? What? Somebody was. Oh yes. I'm in the hostel and I can't control the environment sincerely from where I am. I'm not alone in the room, and I have a lot of crazy people in my hostel. So let's continue. Anyway, where was I? What was I even saying before this? So
We should always use the upper one.
for negative, that's for negative. Why are you choosing the upper one? Because in negative, the upper one is less electronegative. We are choosing the weaker one. This one is weaker. So between OH and Cl, who is weaker? Yes, who is weaker between OH and Cl? Who is weaker? Exactly. So, Okem, over to you. Okem, join me, Okem. Okem. Anodic oxidation reaction. So, Okem, at the anode, OH will be removed. That's what we said. Right? And if we are removing OH, thank you. Let's do this together. Is it going to be by gain or by loss of electron? Remember, anion, exactly, because it's oxidation, so minus electron. And then what it will give is water and oxygen gas. It will give what? Water and oxygen gas. So follow me. Thank you. So follow me, join me. Now watch this. You have to take this over. So it will now be equals OH minus. Sorry, my pen is acting up. Reacting to give H2O plus O2 plus E minus. If we balance this, this will be 4. So okay, how many electrons will be here? Okay, how many electrons will be here? Exactly. So it's going to be 4. Sorry, I hope every other person followed what we just did.
Yes, sir.
Now from this whole thing now, see a question. Look at
Gift does not understand.
Gift does not understand. Gifts, don't you have mouth? Why is somebody talking for you? Gifts. Gifts, what happened? Is Gift not in class?
The reason I don't understand why we had why we had 4 electrons.
You don't understand why we have 4 electrons.
I mean,
Okay, let me re-explain. You know you have a charged particle And I told you that once one side is charged and the other side you have neutral, neutral. This is neutral now, there is no charge. This is neutral, no charge. And you want to find the number of electrons. Just charge times this number by the charge. 4 times 1 is 4. So that's that. Is it clear? Gift.
Yes, sir.
So look at this one, look at this one, look at this one. 2n3 minus reacting to give n2. How many electrons? Oh yeah. How many electrons gift? Gift, how many electrons? No, I can't hear you sincerely. Like I wasn't hearing you. What did you say? Huh? 6. Okay, I hope it's clear now. Should I continue? Class, I hope everybody understood. Should I continue? Okay, now with this said, what I want you to notice, first question I'm going to ask from what we are doing. Yes, whose hand is up? Okay, good. Okay, I saw that now. Good. So let's continue. Now, let's come back. So first question I'm going to ask, what gas is given off at the cathode during the electrolysis of aqueous sodium chloride? What's the answer? What gas is given off at the cathode? What's the answer? What gas is given off? You put you thinking? Correct.
Hydrogen gas.
What gas is given off at the anode?
Hydrogen.
No, oxygen. Oxygen is produced. Now, if I asked, listen, oh, if I said what ion is discharged, you will say hydrogen ion, but after it is discharged, it will produce or give hydrogen gas. Do you understand?
Yes, sir.
Now, if I had said at the anode, what ion is discharged, your answer is hydroxyl. Is discharged. But what gas is produced? After you discharge this is the gas produced. What will it become? Oxygen gas. Is it now clear to everybody?
Yes, sir.
Now, I'd like you to put down this thing. Put down this thing. Put it down.
Just doesn't understand this.
Mr. Come again.
Which place do you want me to come again?
This last explanation that you gave.
Okay, when you say something is discharged, it means you are removing the charge, ba? So at the cathode, who did you remove his charge between the two of them? Is it not hydrogen that we are removing the charge, so it will be neutral? Gift.
Yes, sir. Yes,
So when I say discharge, I mean which ion am I going to remove? So at the cathode, what ion do we discharge here? Hydrogen ion. But what gas do we produce? Hydrogen gas. Is it clear?
yes, sir.
But when we come to the anode, what ion do we discharge? Hydroxyl ion. But what gas do we produce? Oxygen gas. You should be able to know the difference between these two statements because they are not the same thing. Now, after writing this thing, you now write at the anode, oxygen is produced, hydroxyl ion is discharged. At the cathode, hydrogen gas is produced, hydrogen ion is discharged. Oh yeah, please put this thing down quickly so that we can move on. What's the time? Is the time for the class over? Oh my god, I have a class. We'll have to end class here. I'm going to discuss with the management so that we would work out possibly time extensions or more regular time because we need time if we're going to really do things well. And I have a class right now, so I can't continue. Okay?
Okay, sir.
So thank you very much. Remember your assignment. Your assignment is read up what?
Read up hydrogen, oxygen, and carbon.
Now the extra work I want you guys to do for me. Can you please tell me what will happen during the electrolysis of H2SO4 aqueous? Now these are the questions you are going to answer. Number 1, what ion is discharged at the anode? Number 2, what ion is discharged at the cathode? Number 3, what gas is produced at the anode? Number 4, what gas is produced at the cathode? We are not done with this study, but what we've learned so far, you can answer this question. Number 5, does the concentration of the acid increase or decrease after electrolysis? Okay, I presume you've taken note of this. Can I now go off? Hello, have you written this?
So wait first. You said you were going to send. Yes, yes, sir.
Okay.
You said that you were going to send us something. Say, I used to send you.
I was going to send you what?
Eh?
I was going to send you what?
Resources like video,
Yes, I'm going to.
extra resources.
Yes, I'm going to send you, like, our next topic is solubility. So what I'm going to do is I'm going to send you the links to go and start reading up those studies. I'll send a playlist. That playlist contains all the videos. Are you listening?
Is it proper?
No, I'm going to send it to yeah, it's a YouTube video. So I'll send a link. All the studies on solubility, it contains it. So just go and watch it, so that when we start our solubility study, all we'll be doing is solving questions. I hope this is clear.
Yes, sir.
Okay,
Please don't forget to send it
I will not
out.
forget. I will not forget. Okay, thank you very much.
Yeah.
So I presume you are done. Yeah,
Bye.
see ya.
How did it moment you?
Sir,
See you on the next.
How the video is not linked?
no, it's not lengthy. There are like 5 6 studies, each is like 15 minutes. Hope it's clear. Okay, see you
Yes, sir.
guys. Yeah, bye.